going.
I know the area of a circle is.
Well, thank you. That's at the beginning of my recording now, and we're about to do it all together. All right. Area and circumference of circle notes. So, this group over here asked me, they're like, I thought you said we weren't doing this till later on. I said we weren't doing the circles unit till later on. This is not circle units, though. This is just basic area and circumference of a circle. The circle unit gets really deep. It's way deeper than just this. This is just talking about area of a circle and circumference of a circle. All right. And we talked about this the other day, so you can understand again, though. You know, when you find the area of anything, you just find the space inside of that figure. And so now we did area of what? Triangles, trapezoid, rectangle, square, and I'm missing something. Parallelogram. Now you're going to do the circle. The reason we separate the circle because the circle is a different kind of shape. Circle doesn't have sides. All right? So you got to think about it a little bit differently than you think about the other figures. With the circle, we are going to use the pi button. We're going to use pi. We're not going to use the button, actually. If you look up here, we made a note for you. Make sure you always use 3.14. Don't hit the pi button because it's going to give you a little bit different of an answer. Even if you have the pi button on your calculator. We want you to use 3.14 for pi. Alright. So scrolling in a little bit. Formula for area of a circle. Nada, you just said it a second ago. I'm ready for it now. Yeah, pi times the radius squared, or pi r squared. I know, they're always different. Sometimes I make them nice, sometimes I make them, I don't know. Make your pi sign however you think pi sign looks. I make mine in all kind of different ways.
The radius is what? The radius is like.
We're about to talk about that because kids forget what that is. So we're going to make a note out here to ourselves for it. No. Well, it is, but yes. Yeah. So let's write two definitions out here for ourselves because y'all don't be remembering, and I need y'all to know this. Diameter. That's the full length across a circle. The measure of the distance across a circle is the full distance. Full length across the circle. In that same note, I'm writing it small. I just wanted y'all to have it as a note so y'all can remember. Radius half the length across the circle. So with these two, if you have one, you automatically know what the other is because you can do that simple math in your head. If you got diameter and you need radius, cut it in half. If you got radius and you need diameter, multiply by 2. Don't overthink this. You will hurt your head if you do. This is what messes most of my kids up right here when they're doing the formulas. They can't remember what to use. They don't make the adjustment when they need to. Sometimes they use the wrong thing. But I mean, you just cut the number in half or multiplying it by 2. It can't be that difficult, depending on what you need. Or sometimes they may give you exactly what you need, so just work with that. Alright. So 1 and 2 is simple. You just find the simple area of a circle. Find the area of each circle around to the nearest hundredth. Number 1. A, and then you got pi r squared. A equals 3.14 times, Bobby, what's our radius? What number did he just give me?
6. Sound like something John would say.
Yeah. He was like, he made up a number. Radius is 12. Y'all should understand why I wrote 12 times 12, right?
Yeah.
Radius squared. I don't like y'all writing 12 squared because sometimes y'all forget the times it by itself. So, I mean, if you want them kids that want to write 12 and then squared, that's fine. But I like to write it all the way out because I've seen it so many times and I've been teaching this for a while. When y'all write 12 squared, most of y'all forget the times by 12 twice. Just write it out. It's just, you won't forget. Oh, area to the nearest hundred. 452.16. Good. This is meters squared. It's area, so we still squaring our units. Sweet. Number 2. Area equals pi r squared. Christian, number 2. Area equals 3.14 times, what's our radius, Christian? I don't know what I just called you. 17.5. Good. How you got that? 35 divided by 2. So yeah, 17.5. Area equals
161.6.
one more time.
961.6.
63. Thank you. 961.63. What is this? Kilometers. Oh, cut off my square. Sweet. So that's simple area. Let me help you understand what you were finding because they didn't show it on here. You're finding the space inside the circle. All the space in here. This is what you were finding when you did area of the circle. Finding the space inside of it. Same thing on this one. I found the full amount of space inside this circle. That's what I was finding. Now, I could teach a 6th grader to do that. Geometry in high school, we're going to use area to find area of a sector. This stuff down here. Area of a sector. A sector is a portion of a circle bounded by a central angle and its intercepted arc. ARC. Let me zoom out so you can see all that. So a sector is a portion of a circle bounded by a central angle and its intercepted arc. When you're thinking about a sector, you want to think about pie, or some people think of pizza. Like a slice of pie or a slice of pizza. Alright. So when you find an area of a sector, you don't want to know the area of the full circle. You just want to know the area of that portion of the circle, that slice of the circle. To figure that out, you would need to know what angle that slice represents. So let me talk to you about a circle and make some connections with you, make this make sense. So a full circle, a full rotation is what? 360, right? So when we're doing area of a circle up here, we're just finding out the full 360 area of the circle. So that would be represented as a whole, right? 360 over 360, which would be a whole. If I wanted to know a portion of the circle, I would still use the area formula, but I need to multiply that by what fraction of the circle I'm trying to find. So for example, say this fraction of the circle was 90 degrees. Yeah? 90 is, and I know this isn't 90, definitely not. 90 would be out here somewhere. I'm just trying to make the connection with you. Would you agree with 90, that 90 is a quarter of the circle?
Yes, I would.
You agree? Quarter, 1/4 of a circle? Think about it. And then 360, right? So what you're really trying to do when you find an area of a sector, you want to multiply that quarter that you're trying to find. Say we're trying to find a 90 degrees portion of a circle. That we will multiply 1/4 times the area of the actual full circle, and that will tell us what that 90-degree section will represent. The reason I'm going through saying all this because that's all we're doing in this formula. I'm about to write a formula, and I think y'all get freaked out with formulas. But I want to explain to you where the formula is coming from first before I write it. It's really not complicated. I'm not going to add much in. So formula for area of a sector is K. K represents area of a sector, lowercase k. I know we've used K before on scale factor, but it's for this too. Equals X over 360 times basically area of the circle, which would be pi r squared. All we're doing is taking the area of the circle, multiplying it by what fraction of the circle that we need. To find that fraction, you're going to put your degree over 360, and that'll tell you what fraction of the circle you need. So like I say, if I was to do 90 over 360, that reduced down to 1/4. It's basically telling you I need to know the area of 1/4 of the circle. If I was to do 180 and reduce that, that reduced down to half. I need to know the area of half the circle. You feel me? And we don't even have to reduce the fractions. We could just get the decimal in the calculator and multiply it by the area and keep it moving. So let's handle that. Keeping that in mind. Oh, let's look at it though. Two things you need. You're gonna need the degree of the angle, which is a central angle. I ain't even talk about that. Let me mention that while we at it. It's a new term for y'all. Central angle, but it should be common sense. Angle, you know what that is. Why the word central though? What about the angle makes it central? No, I mean it's in the center of the circle, ain't it? It's an angle coming from the center of the circle. Now this angle, they're saying it's intercepted by this arc up here. This angle and this arc are the same degrees. And we're going to make that connection further when we get in the circle. But I want to talk about it now just to start the connection. This angle, say whatever it was, say this angle was 45 degrees. That means this arc out here, this big arc that it's intercepted by, will be 45 degrees as well. Both of those things are 45 degrees. It don't matter. The angle in the middle and this arc that it goes along with. So you might see me move a number in and out of the circle. Just understand they both the same. Alright. Down here, find the area of each shaded sector, round to the nearest hundredths. So, round to the nearest hundredths. This first one says BC is 16. What's BC? What's BC represent for us? That's what? That's our radius. They're telling you that because you need a radius. And then the angle that we're trying to find of the shaded area is 51 degrees. So we're going to use that. So K equals 51 over 360 times pi 3.14 times our radius squared. Our radius is 16, so 16 times 16. In the calculator, do the, ain't no lot. And it's like 5 numbers.
5?
51, 360, 3.14, 16, 16.
Jesus.
Do 51 divided by 36 in the calculator first, then multiply by all the other stuff. What y'all got? Make sure y'all put this in the calculator so you can see it too.
113.
Cause some of y'all still don't know how to round around here. One more time, 113.88. Got it. So this was feet squared. We're still finding area, so feet squared or whatever squared. Yeah, ones like that. That's all there's to it. Sliding over. Number 4. PQ is 22. Gave us 139 as our central angle. So K equals 139 over 360 times the area, which would be 3.14 times 22 times 22. Because 22 is our radius.
586.
One more time.
586.8.
Yeah. That's not bad. Young blood, you still with me? I'm just checking. Alright. I don't want you to miss this. Number 7. See where y'all brains go. I need to find the area of the shaded region. Let's talk strategy first. Christian, what you gonna do for number 5? Well, I don't want to write it yet. I want to make some adjustments first. Tyree, what you gonna do, bro? How you know they equal? He about to show me. I just want you to say one word to let me know that you know that they equal. Somebody give him the word. There you go. That nigga put an X up. 46 degrees. Alright. So 46 plus 46. What's the total shaded area? 92 degrees. So we want to use 92 degrees in this one. So K equals 92 degrees over 360 times 3.14 times HG was the radius, so 7 times 7. Huh? Yeah, only reason I don't want you to do that, and I told him this last period, I'd rather you get the total amount of angles first because you can't take that same approach on the next one because it's different. I'd rather you figure out the angles first and then do it. You feel me? Because if you think that way, everybody, like some kids, I know y'all might, on the next problem, you're going to think you can be able to do that same thing. You can't. CJ, you paying attention over there? You got the next one. K equals what?
39.32.
One more time.
39.32.
What is this? Centimeters squared. Alright, CJ, number 6. Give me some strategy, man. How you gonna solve this? Ain't no vertical angles in here.
62 plus 62.
How we know you got the shade?
Oh, okay.
You got the white one.
I know you know. No. I need them to know. I need to talk to them. What you saying?
I said 62 plus 62.
So you think you do it the same way you do the last problem?
I want to try. I might be wrong though.
Oh,
I'm gonna try.
360 divided by 3?
No, man.
No, 360 divided by 6.
No. Stop.
No, 62 times 3, then you gonna subtract.
I was going to do that.
Explain why. Shh. Can you explain why?
She don't know the whole thing is a pop.
And it's 3 up. Shut the fuck up.
Oh,
Oh, you recording. My bad.
She finna leave me.
I'm sorry. I truly apologize. You know I don't curse when he's not interested.
Oh, you were doing so good. So, all these are 62. Shh. What I think you were trying to say before you went all left. 62 degrees times 3 will tell you the area that you don't need, which is 186. But then from there, to figure out the shaded region that you do need, you could just subtract that from 360 because full circle equals 360 anyway.
So 360 minus 186.
Yeah,
174.
174. And somebody last period, they're like, oh, you could divide it by 3 after that. What's the point? No, it ain't. Yeah, because you're just going to put them all back together because you need all these shaded regions anyway. You just need to know that. I know you were. So, K equals,
174.
uh-huh.
Or 360. Times 12. I'm going to keep it. People on for it.
I was about to write it too.
Uh, 218 and then 54.
One more time.
218 and 50.54. I've never seen this video. That boy.
Alright, so if you're comfortable with that, that's area of a sector. Now on the back, switch your brain over. I'm talking about circumference of a circle on the back. So let me give you a whole explanation and go around and around for this so you can understand it. So circumference, that's the length around the circle. I know in any other shape we would call the length around another shape, we would call that perimeter, right? But it's a circle. It don't have no sides, so we can't call that perimeter. We got to call it something else. We call it circumference. It means the same thing, though. It's the length around the circle. To find the length around a circle, the circumference, the formula is 2 formulas, actually. The first one is the one I want you to use. I'm going to show you the other one, but I'm going to explain to you why I don't want you to use it. They both mean the same thing. Shh. Circumference is pi times diameter.
That's what you don't want to use?
Yeah, the one up there is the one I don't want you to use. It came with the poster set. You would get the exact same answer. I'm explaining to you why I don't want you to use it. So the other formula, which means the exact same thing, is 2 pi times the radius, the one that you see on the wall here. The reason I don't like y'all using this formula, and somebody did it in first period or second period before I even said anything, you mix this up with the area formula on the front. Look at this formula, look at the area formula on the front. Y'all mix it up, even though those 2's are not in the same spot and mean different things. Kids mix them up all the time, and y'all screw this up. I'd rather you just use this for circumference, pi times diameter. Only reason this formula down here has a 2 in it is because they gave you the radius in this formula. Radius is what of the diameter? That's why you got to multiply it by 2. That's why they put a 2 in this formula. It's the same formula, though. All this formula is really saying is 2 times the radius, which is diameter, and then times pi. This one up here just says pi times diameter. It's the same thing. It's just that I'd rather you not use this one because y'all mix this up with the area formula on the front, which means something totally different. So I'd rather you just stick to this and understand that you just need diameter for circumference. So anytime they give you radius, just double it in your head. Or, I mean, if you got to do it in the calculator real quick, do that. And then put the diameter in. All right. Number 7 and 8 says find the circumference of each circle. This is the length around the circle, round to the nearest hundredth. Bobby, I come back to you. You know, I'm never quite done with you. Bobby, circumference is pi times diameter. C equals 3.14 times what, Bobby? You ain't saved by the bell. Let's go. Huh? Good. 3.14 times 14. Circumference equals what, Bobby? Put it in the calculator, man. Let's go. Say it one more time.
It ain't that no more. 3.9. Oh, yeah.
Alright, listen to me. Shh, so you don't mess this up either. This is circumference. This is not area. All we're doing is finding the length around the side of the figure. Our units are just regular units. This is just millimeters. Don't put a squared on the end. This is not area. All this is a length. No. Huh? We're gonna do the ones at the bottom. I got one for you. And you gotta talk us through it. Number 11 is yours. How about that? Number 8. Damn. That's too easy, son. Go ahead, Tyree. Huh? Okay. A little bit louder. 32.03. Thank you. This is meters. No, I just told you why. This is not area. This is just length around a circle. It's just like if we do perimeter. Perimeter would just be in regular units too. Area is 2 dimensions. It's gonna be units squared. Alright, arc length. So, similar to what we talked about on the front, but now you got to think about the fact that we're talking about a length around a circle. Say I don't want to know the full length around a circle. Say I just want to know half of the length. Say I want to know a quarter of it.
Well, this is what you're talking about with that arc.
Yeah. Now, listen. It's the same process except for I'm multiplying my fraction times the circumference this time, which would be pi times diameter. So the formula for arc length is L. It's a cursive L too. I don't know how to make my cursive L's that good. I mean, it's up to you, man. X over 360 times the circumference, which is pi times diameter.
What would X be, the arc that we're talking about?
All right. So now we're looking for arc length. Not the full distance around a circle, but part of the distance. So find each arc length, round to the nearest hundredth. And number 9, it says EB is 15. And then it says find the length of, what you think that say right there? It's a new symbol for y'all. What y'all think it say? There you go. Find the length of arc CD. I'll mark that off for myself so I know what I'm looking for.
Yes, sir.
Bold it on your circle. Unless you got different colors, use different colors like me. My bad. Well, I'm using a pen, man. I'm trying to write back and forth. God, I can't stand you.
Thanks.
That's really horrible, bro. That's sad.
So we need to find the length of arc CD. First of all, they didn't give me an angle for arc CD, so I need to find that for myself. How do we find that one? Say something smart. No. Somebody help me out. How we find that arc? Nadi, you could jump in on this one.
So it's 30, 68 times 2.
No.
Hey, we put it
60
how?
over 360.
Look at it.
Oh, wait, is it adjacent? Something like that?
Oh,
No, it's a verse.
No. That's not what we need to know. CD is right here, man. I need to find the arc CD. I ain't gonna find it. Lizzie, you raise your hand and put it back down.
68 minus 360.
No.
You see my.
Come on, Christian. You about to say something silly though?
Yeah, I think we gotta do 360 minus.
No.
How you know about? I never seen
The
it.
diameter is the entire thing. So you have just 68. So you have that, and then you you have, so it's just one length. So you.
I can't believe y'all. This happened very quickly last period.
I have the answer right here. I just don't know how to explain it.
If you're gonna whisper, I'm not gonna be able to hear you. Yes, yes. Shh. Quiet. What'd you say? You got all our attention now. She doesn't like all that attention, guys. With what? You gotta explain better than that. You just said one word. I agree, but they don't know what you mean. She ain't gonna say it. Shh. Listen. Shh. Let me show you what she's seeing. What you all should have seen. BD is what?
What are you doing?
BD.
He is 30. Oh, 30.
It is a line, though, isn't it? You talking about it's a nasty line. Is it a line?
Yeah.
Anyways, it's 30.
So, you can't find that angle right there?
Oh my goodness.
Oh my God.
It's supplementary. I mean, linear. Oh, that's what I said adjacent.
I figured you was probably going there, but Jason ain't good enough.
So 180 minus 68.
Yeah.
122.
You can't subtract.
Yeah. Always at the 10. It ain't gonna work. It ain't.
Tyree, you ready to go outside? This happened very quickly in another class. I don't know why y'all can't see it. I know, I could tell.
I know. Thanks.
Alright. Your class. I think it was a couple people that said it. Shh. Mike, though. I think Mike was the one that said it, though. Alright. So 112 over 360 times 3.14 times, what's the diameter? 30.
That's cute. 29.
What now?
31.
It's 20 dot point.
I said 31. We already got that, but
You got that like
The next one. Shh. Make sure y'all stay with me too.
do we square it?
No. The next one, if NR equals 8, find the length of arc NMP. NMP, they use 3 letters on this, and they use it a lot of times when you have a major arc. A major arc is an arc that's more than half of the circle. A minor arc is an arc that's less than half of the circle. An arc that's half of the circle, we just call that a semicircle. So I'm going to mark it. The best thing to do is go through the points. It says N, M, all the way around to P. This is the arc they want us to find the length of. Arc NMP. I marked it for you. Somebody gave me strategy. They gave me MQ. That's that arc in there. I need MN and I need QP. How am I find it?
Would you have
Did too much. Okay. And then after that?
you subtract that angle from the side, and you add them together. And add that with.
You're confusing me.
I know, I'm confused too. You just add another. And then you subtract together.
Oh, you get the 180, and then you get that 180, and then you add them together.
You get MN, and then you multiply by 2. Because you have QP.
Okay. I can take that. Alright. Shh. So they taught me through it. They whispering though, so I said out loud what they said. So they said, first you need to find one, either MN or QP. To find MN, you should be able to see that from N to Q here is another straight line. So I can do 180 minus 162, and I'll get this angle right here. Once I get that angle, I should know these two angles are congruent because vertical angles again. So once I get this, I'm going to just write whatever I get over here. And then I'm going to add all that up, and that should give me the full thing. So 180 minus 162, that's 18. So 18 degrees here, which would in turn be 18 here. And like I said, this 162 outside, I don't understand. It could be written in here too. This could be 162 right there. So then you need to add all three up. 198. So I'll do it down here at the bottom. 162 plus 18 plus 18 gives you 198. This is what I want to use to find my arc length. So L equals 198 over 360 times 3.14 times, what's my diameter on this one? 16. Alright. And she just getting back? Oh, you got a referral. Oh.
29.92.
Met your PO office?
Mr. Bronson, 29.92.
Say it one more time.
29.92.
That's what y'all got?
No.
I about to say that sound a little wrong.
My bad. You got it. Alright, guys.
You violated?
27.86. What are you doing?
Y'all proud to have parole officers?
I didn't know
Alright, moving on. Alright, you need to pay attention. Number 11. Number 11 got a lot going on, and it's different ways you can look at it. I'm going to see which way Nadia looked at number 11. So on this one, it says a VS. And first of all, you need to pay attention on this one. It said VS. VS is what? VS is the diameter. So I don't need to double this. They already gave me diameter. And then it says find the length of arc UT. Arc UT is this one down here at the bottom. Hold on. Got too many people talking. If you're going to be in here, you need to hush and let my kids focus.
Okay, my bad, y'all focus. So I found, like, I did 180 minus 127 to find the angle right next to it.
Right next to it. Name that angle, please.
Where W is.
Okay, that angle. I got you. So she's saying she did 180 minus 127 to find this angle right here. Because I guess she saw a straight line here. Let me indicate. Oh, my lining.
So I got 52 degrees.
So 180 minus 127.
And I put 53 like on the other side of W since it's like vertical angles.
One over here. Even though you don't need to. Okay, I put it over there. You don't really need to.
And then I did 180 minus 90 minus 53 to get the small angle on that side.
Oh, I see. So she took a little bit of different path. So on this side, she saw a straight line over here. She said she had 90, 53. She added that together, subtract that from 180 to get this angle right here.
37.
So she did 180 minus 90 minus 53 over here and got 37 degrees. Alright.
L equals 37 over 3.
Hold on. So, y'all okay with that? That's one path to take. That's a path we kind of took last class. But that is not the only way to get to that angle in this problem. There's multiple ways of doing this. You find your own way, that's fine. I just need you to get 37. What's up?
I was gonna go for the other way.
What's another way you think you should tell me out loud? Let's see if you got it.
Basically did the same thing. But with the other way around.
Okay. I got you. You just went the opposite. You probably use BS as a straight line. I got you. Check this out. This is what I would have did. I mean, you got to be able to see it like me, though. It's to make it shorter. Casey thought he had a shorter way. His was just as long last period. But right here, a V to R is 127. This angle, I'm marking it orange. I see that as 127. That's what it told me. I also see an angle vertical of that one. That could be 127 as well, which would be this full angle over here, US. If that's the case, I could have just did 127 minus 90. And I would have got 37.
Oh, that makes sense.
I did L equals 37 over 360 times 5 times 12. I got 3.87.
Yeah. And your number is going to be small on this one because you got a small fraction. It's 37 over 360. So times 3.14 times 12. What's that decimal again, Nani? Yeah, 3.8 something. Huh? You can do it with me real quick. So that's that one. Number 12. JH is 21. You should recognize that JH is the diameter, so you don't have to do nothing with that. It says find the length of KJG. You need to mark that for yourself. Oh, yeah. We got to do number 12. KJG. That's pretty much the full circle. Almost. You're just missing a short piece. KJG is all the way around. That's a major arc. That's like everything except for KG. Somebody come up with strategy. Tell me what you're going to do.
HJ is a full line.
I started also thinking well, KI to JH is like vertical angles.
KI to JH. I don't see what you're saying. Yeah, I'm going to let Ruben do this one. Go ahead, Ruben.
So JH is the 180. So
No, don't let Ruben do it.
Right there.
I don't even want to go that far, Ruben. I can make it simpler for you. Shh. Hold on. Just like I told you on the last one, I kind of mentioned it to you. JI right there, that angle 85 degrees. What is that congruent to? KH, good. So if KH is 85, what would KG be?
It would be 26.
Huh? No. No, if KH is 85, I know that. I'm saying what would KG, the small piece, be looking for? Yeah. 85 minus 59. My God.
It's like what I did was instead I didn't start out. I didn't do the whole 5.
It ain't wrong, it's just long. This is just simple. So that's 26 degrees right there, but that's not what we need. We need everything but the 26 degrees. So what are we going to do? 360 minus 26. 334. That's the degrees we need right there. L equals 334 over 360 times 3.14 times our diameter, which was 21. And then you give me that answer. I believe you.
What is it? 61.25.
Excuse me, say that louder so they can't see you.
Only messed it up once again.
So you're gonna record in my class?
I haven't decided yet.
Yeah, you can record in my class.
You messed 2 of my videos up twice now.
It will be 61.